Okay, one final demonstration of logistic regression. For this, we're going to be using our old friend, the MplsStops dataset, along with the demographic info. All right, and those are found in the carData package. Load that up, load modeler for doing our predictions, tidyverse for cleanup. All right, so we've got our data sets in there now. Alright, if you remember this one, we've got the date, whether a citation was issued, whether person or vehicle was searched, race, gender, latitude and longitude, and then neighborhood. And then we've got our demographic information, which links that neighborhood column from the stops dataset to give demographic information. The population in the neighborhood, the percentage that are white, black, foreign born, the median household income, poverty level, and college graduation rates. Okay. So, a couple things. I'm looking at these. If I look at, for example, vehicle search, meaning I want to model what makes a vehicle search likely in a given police stop. I look at that, and down here I see levels. What's that mean? Yep, it's a factor. Alright. Remember, for logistic regression though, I want that to be true false. Alright, so I got to turn these no's and yeses and NA's into something meaningful. Alright, so first off, I'm going to convert to a character. Alright, look at that again. There, we got our character. I'm going to take that column, the ones in that column that are equal to no, and then I'm going to turn that to false, and then do the same for yes and true. Okay. Another thing I'm interested in is the probability of a citation being issued when somebody's stopped by police. So look at that, same problem. Levels, no, yes. So convert to character. Citation issued no should be false, yes, true, and then if it's NA, we're going to call that false, because it definitely didn't get entered into the system, so no citation was issued. Okay. So converted those. I'm going to look at a table of that new column. All right. So we've got some falses and some trues. Almost 49,000 falses, only 3,211 true. So of all the people, 51,920 that were stopped in this Minneapolis data set that year, only 3,211 citations were issued. What about vehicle searches? Well, table, MplsStops, vehicle search. 3,120 vehicles were searched. Okay. So one of the things, I'm looking at this, so if I should say names, MplsStops, we've got date, whether citation was issued, person was searched, we've got whether the vehicle was searched, pre-race, that's mostly NA in this data set. We got the person's race, gender, latitude and longitude, precinct and neighborhood. I'm curious about gender, whether that influences whether citations are issued or vehicles are searched. All right, so I'm going to get rid of all the unknowns to kind of clean up my chart at the end. Okay, so we found the ones which gender is not unknown, and we kept those. Now I'm going to join our two data sets. Our MplsStops here, now down to 37,000, and MplsDemo, and I'm going to join them on that neighborhood column. So we got DAT. Alright. So we look at DAT, we've got all our citation stuff, gender, Latin long, neighborhood, and then info about that neighborhood. So we can use these as predictors. So final step in the cleanup, I'm going to take dat vehicle search. Where is it? Okay, false, false, false. Sure, but it's still listed as a character over here. I want to turn that into logical. Same with citation issued. So I'm just going to say as logical right over those. Alright. So looking at these, I've made 3 models here. First model is a logistic regression. So generalized linear model, data equals dat, and then here's my formula. Whether the vehicle was searched, true or false, as a function of race, gender, and household income. I put family equals binomial again because this is a response variable is true false. Alright, model 2. Now I'm looking at citation issued instead of vehicle searched, so that's true false. It's a function of race, gender, and household income. And then third model, I'm looking at vehicle search again with race, gender, household income, and black. What, pray tell, is black? Well, let's take a look. We've got our original data here, and remember all these built-in data sets, like MPLS demo, I can just do question mark MPLS demo. Okay. So neighborhood, name and neighborhood, total population, black. The fraction of the population estimated to be black in a given neighborhood. Alright. So here, I added that to this model to test whether the neighborhood demographics influence whether a vehicle was searched, as opposed or separate from the driver demographics. Alright. So I'm going to add predictions, make 3 new data sets, 1 for each of these models just for our convenience here. Add predictions. The data we're using to make predictions from is dat. Our model is mod 1 in this case. And remember, type equals response because I want the outcome, our predictions, to be probabilities. Alright, so add predictions there. Mod 1 not found. Okay. Didn't run the models. Now it works. Alright, so we've made our predictions. Let's just check on one of those. There it is, our prediction column. Alright, so this first row here, this person had a predicted chance of being searched at 1.2%. Alright, there was a suspicious, whatever that means. Citation was not issued. Person and the vehicle were not searched. Unknown race, male, at these latitude and longitudes, that police precinct. And here's the demographics. Okay, that's what our model told us. Now let's take a look at a plot. I'm going to look at DAT2. That was the one predicting vehicle search based on race, gender, and household income. Okay. On my x-axis, I'm going to do household income, a nice continuous variable. Y will be pred, so the predicted probability of a vehicle being searched. And I'm going to color it by race, draw a smooth line, and then kind of make it look pretty, and facet it based on gender. Alright. Well, here we go. So, as household income increases in a given neighborhood, the probability of a vehicle being searched that was stopped in that neighborhood goes down. Alright, pretty nice consistent trend there all the way across. So, don't drive in poor neighborhoods or you're going to have your vehicle searched, I guess. Alright. Now, I split this up on race. So we've got, if the driver is black, their probability of having their vehicle searched is greater than a Native American, which is greater than Latino, then other, and then Asian, and then white down here, and then East African, and then unknown. Okay. So there does seem to be a difference, right? Matter of fact, let's take a look at that. Summary. Oops, I'm gonna move this down here. Summary mod 1. Okay, so here's our coefficients. Let's see. Okay, so our intercept here, since race was categorical, all right, all these other races and are being compared against the black race. All right. So if you are white, you have a smaller estimated probability that is statistically significant. All right. If you're Native American, it's not significant. Significantly different from black. Okay. So we look over here in our plot, and sure enough, there's black, there's Native American. Those two are not different. That's what this is telling us. Okay. All right. Race other, it's different. We see that that's smaller. Okay. Asian, different, smaller. Now, gender male. What's missing here? Well, female. So it's just comparing the male versus female. There is a difference. It's significant between males and females. And look at that. The estimate has a positive sign on it, not negative. All right, so we look at our chart, and sure enough, you are much more likely to have your vehicle searched if the driver is male than female for all the races. And interestingly, the races fall in the same order on both of these. Okay, so that's how we are interpreting this. Again, remember that this is not reality. There was, our y-axis here is not whether the vehicle was searched, it's the probability given our underlying data. So we looked at reality and we made a model of it, and this is what we're being shown. Alright, so let's take another look. Here we've got household income on the x-axis again. Pred, race, all that's different here is that we're doing DAT3, and so this is the predicted probability of a citation being issued, not the vehicle being searched. Okay. This is interesting. As household income goes up, looks like your predicted probability of a citation being issued also goes up. Okay. And the races are in a different order now. Black is still up there. Latino overtaking black, though. Congratulations, I guess. You're worse off. Let's look at that model summary. And that was mod 2. Okay. So, yeah, there you have it. There's Latino. Looks like an increase, but not significant. Okay, so this blue line, that red line are not significantly different from each other. But white is, unknown is, East African is, Native American is, and other is, and Asian is not. Okay, so actually those first 3 lines are not significantly different. Okay, and then household income is a significant predictor, right? So as we increase household income, we increase our probability of a citation being issued. Now, DAT4. This is the one where I also included the neighborhood racial component, not just the driver. So let's see here. Alright, Males are still getting citations at a higher rate than females. Black and Native American look like they're overlapping here. But our x-axis is not household income, it's the proportion of black residents in the neighborhood where the stop happened. Okay, so look at this. White people, this orange line, orange whatever, burnt sienna, they get stopped and citations issued more often in neighborhoods with more black people. Interesting. All right, so this is just kind of showing you the power of logistic regressions. All right, especially when you make predictions like this. It's really nice when you have a continuous x-axis, okay, and maybe some categorical stuff that you're looking at, to plot this probability of the event happening. Kind of gives you an overview of what's going on in your data set. 3. Alright, what's not significant? Native American. Yeah, okay. So those are overlapping. And the rest are significantly different. Okay. Your probability of having a citation issued, regardless of your race, goes up 1.9% for every increase of, what would it be? Increase of 0.1 in the proportion of black residents in that neighborhood. So regardless of your race. Right. Interesting stuff. Shows you the power of logistic regressions. So a lot of you might be using logistic regressions in your final projects. So this is kind of a nice way to look at them. Cool. Jeff out.